The electrical system generates and distributes AC and DC power to airplane systems. The AC system operates on 115 volt at 400 Hz and consists of two engine-driven integrated drive generators, one auxiliary power unit generator, one ram air turbine generator, and one AC external power input. The DC system operates on 28 volts and consists of two nickel-cadmium batteries and one DC external power input. Three transformer rectifier units convert AC to DC, and one inverter inverts DC to AC. Four integrated control centers and two secondary power distribution assemblies provide distribution and control of the power and interface with other systems. On the cockpit overhead panel, the pilot is able to select or deselect power sources and buses. Indications are shown on the synoptic page, Electric, and the ICUS. In case of short circuits, several circuit breakers prevent overload of the system. The integrated drive generators are the main AC and power sources when the engines are running. They are mounted on each main engine gearbox. A hydromechanical constant speed drive, CSD, converts variable engine speed into constant generator speed. Each IDG generates constant frequency AC power at 40 kilovolt amp, 115 volt, 400 Hz, three-phase. The IDG oil system is air-cooled. The IDGs are monitored and controlled by the Generator Control Units, GCUs.
The IDG selector knobs are located on the cockpit overhead control panel and must be in the auto position during normal operation. When selected to the off position, the respective generator line contactor opens, and the selected IDG will be tripped offline and de-excited. A related message on the ICAS indicates that the IDG is offline. An amber LED associated with the ICAS message IDG 1 or 2 oil illuminates, indicating to the pilot which IDG must be disconnected. By selecting the knob to the disk position and holding it in this position for 1 second, the IDG will mechanically disconnect and the amber LED will be off. Note: only authorized maintenance personnel on the ground can reset a disconnected IDG. For safety, the IDG features an input shaft shear section and a thermal disconnect operation. This will disconnect the IDG permanently if there is no manual disconnection.
The auxiliary power generator is the secondary power source on ground and in abnormal operation in flight. It is mounted on the auxiliary power unit. With the APU at constant speed, the generator supplies constant frequency AC power. The generator provides 40 kilovolt amp, 115 volt AC, 400 Hz, three-phase. The lubrication system shares the oil cooling system with the APU. The APU generator switch on the cockpit overhead panel provides control of the auxiliary generator and must be pushed in during normal, automatic operation. If the switch is pushed out, the auxiliary generator line contactor opens and isolates the APU generator from the AC bus tie. A bar illuminates inside the button when it is pushed out.
The ram air turbine, RAT, provides emergency AC power for the electrical system whenever, in flight, AC power sources are not powering AC buses, and is installed in the right nose section of the aircraft. If there is a sudden loss of AC power in flight, the ram air turbine is automatically deployed into the airstream. The kinetic energy of airflow across the turbine is converted into mechanical power to drive the generator. Automatic mechanical variable pitch angle of the turbine blades converts variable airflow into a constant generator speed. The generator produces 15 kilovolt amp, 115 volt AC, 400 Hz, 3-phase. In flight, there is no altitude restriction for ram air turbine deployment. If ram air turbine automatic deployment fails, an ICUS warning message, battery discharging, illuminates. The ram air turbine can then be deployed manually by the ram air turbine lever located on the center pedestal. One static inverter provides backup AC power whenever the electrical system is only on battery. The inverter is located in the forward E-bay. AC power is generated by conversion of DC to AC power. The input of the inverter is 28 volt DC, and the output is 115 volt AC, 400 Hz frequency stabilized, single phase. 3 transformer rectifier units are the main DC power sources whenever an AC source powers the aircraft's AC buses. TRU-1 is located inside the left integrated control center. TRU-2 is inside the right integrated control center, and TRU Essential is inside the emergency integrated control center. DC power is generated by conversion of AC to DC power. The input of each TRU is 115 volt AC, 400 Hz frequency stabilized, and the output is 28 volt DC, rated at 300 amps of current. The TRU toggle switches on the cockpit overhead panel provide control of the 3 transformer unit contactors and must be in auto position during normal automatic operation. If a switch is set to off, the respective TRU contactor will open. 2 nickel-cadmium batteries are the secondary DC power source. Battery 2 provides APU start, and until the ram air turbine is working, both batteries power backup DC essential loads in case of total power loss. Battery 1 is located in the forward E-bay and battery 2 in the aft E-bay. In normal operation, any available AC source will provide charging for both batteries. The battery switches on the cockpit overhead panel provide control of the battery contactors. With the switch in the off position, the respective contactor opens and the battery energizes only the hot battery bus. With the battery 1 switch in the on position, the battery contactor 1 will close. With the battery 2 switch in the auto position, the battery 2 contactor will close, except when an APU start is in progress. This causes battery contactor 2 to open. The Integrated Control Center is an electronic device which provides power distribution and protection for the airplane electrical loads. 4 ICC are installed. The left and right integrated control centers are located in the middle E-bay. The Emergency Integrated Control Center is located in the forward E-bay. The Auxiliary Integrated Control Center is located in the aft E-bay. Each ICC has incorporated AC and DC buses, thermal circuit breakers, and line replaceable modules. Thermal circuit breakers in the ICCs are remote circuit breakers. They can be monitored via the MCDU in the cockpit. If a thermal remote CB trips, an ICUS advisory message, Remote CB Trip, illuminates. Note, thermal remote CBs in the ICC can only be reset on ground by maintenance personnel. The left integrated control center provides power distribution and protection for AC bus 1 and DC bus 1 and the AC and DC ground service buses. Line replaceable modules in the LICC are the Transformer Rectifier Unit 1, GCU 1, the external power module, and several thermal circuit breakers. The right integrated control center provides power distribution and protection for AC bus 2, DC bus 2, and DC essential bus 2. Line replaceable modules in the right integrated control center are the Transformer Rectifier Unit 2, Generator Control Unit 2, GCU, Auxiliary Generator Control Unit, ACGU, and several thermal circuit breakers. Note, the DC Essential Bus 2 is located in the right integrated control center instead of the Emergency Integrated Control Center. This provides DC essential loads in case of damage to the forward E-bay, where the EICC is located. The Emergency Integrated Control Center provides power distribution and protection for AC Essential Bus and DC Essential Bus 1 and 3. The Standby AC Bus and the Hot Battery Bus 1 are also integrated into the control center. Line replaceable modules in the EICC are the Essential Transformer Rectifier Unit, several thermal circuit breakers. The Auxiliary Integrated Control Center provides power distribution and protection for APU Start Bus and Hot Battery Bus 2, and several thermal circuit breakers. The Secondary Power Distribution Assembly, SPDA, is an electrical loads management and power distribution device. It distributes power from the integrated control centers as dictated by logic calculations and specific airplane configurations to several aircraft systems. 2 SPDAs are installed, one in the forward E-bay and the second in the mid E-bay. Each SPDA has a number of slots where different electronic modules are connected. Each module has an associated function that provides communication, data processing, and power distribution. Electronic remote circuit breakers are located in the SPDAs. They can be monitored via the MCDU in the cockpit. An ICAS advisory message, Remote CB Trip, illuminates if an electronic remote CB is triggered. Note, electronic remote CBs in the SPDAs can be reset from the MCDU in the cockpit. Circuit breakers can be either electronic or thermal circuit breakers. Electronic CBs are located inside the secondary power distribution assemblies and may be reset from the MCDU. Some thermal CBs are located inside the integrated control centers and cannot be reset in flight. Vital system CBs, such as those for computer reset and power interruption during maintenance, are located on the circuit breaker panel in the cockpit. Columns and lines on the circuit breaker panel are identified through an alphabetical and numeric columns code. Several units of the electrical system have built-in test capabilities. They detect, isolate, and locate faults that occur in the unit. These units are Generator Control Units, Auxiliary Generator Control Unit, External Power Module, and Secondary Power Distribution Assemblies. The built-in test capability has 3 levels: Continuous Built-in Test, Fault Initiated Test, and Initiated Test. Results of the built-in tests are shown on the ICAS for crew reaction and sent to the Central Maintenance Computer, CMC. The normal operation of the electrical system is automatic. Two independent networks provide complete segregation for electrical fault isolation. The left engine's IDG, IDG1, normally powers AC bus 1, and the right engine's IDG, IDG2, normally powers AC bus 2 and the AC essential bus. Each AC bus powers a dedicated TRU, which rectifies AC to DC power, supplying DC buses and then DC essential buses. If a generating power source fails, the electrical system logic provides electrical power to the bus from another source according to the following priority. First, on-side integrated drive generator. Second, APU generator. Third, GPU if on ground. And fourth, opposite IDG. One AC source can supply the entire electrical system. When a total loss of AC power occurs, the emergency generator will automatically deploy, supplying all essential buses. With power source failure, tie buses achieve connection between the networks. The respective AC bus will be powered by the other AC bus through bus tie contactor, BTC 1 or 2. On the cockpit overhead panel, the AC bus tie's rotating switch is normally in the auto position, and the electrical system controls the bus tie contactors automatically. In the 1 open position, bus tie contactor 1 opens and isolates AC bus 1, and in the 2 open position, bus tie contactor 2 opens and isolates AC bus 2. A BTC lockout system provides system protection.
Generator control units. The GCUs 1 and 2 are LRM, line replaceable modules, located in the left and right ICC, Integrated Control Center, respectively. The GCUs give control, protection, and distribution of the IDG electrical AC power to the AC buses by sending signals to close the respective generator line contactors. Both GLCs 1 and 2 are also located in the left and right ICC.
Electric power from an external source may be supplied to the airplane through an AC or DC receptacle. AC ground power is used for flight preparation and maintenance. DC ground power can only be used for APU start. The AC ground power receptacle is located on the left-hand nose section of the aircraft. The DC ground power receptacle is located on the left-hand aft section of the aircraft. Indications are shown on the electric synoptic page. Releasing the parking brake when AC or DC ground power is connected causes an ICUS caution message, GPU connected, to illuminate. The AC ground power system accepts 115-volt AC 400 Hz 3-phase. The ground power module, EPM, in the left integrated control center controls the operation of the system. The ground power unit switch on the cockpit overhead panel controls the ground power AC contactor. If power quality requirements are satisfied, the avail annunciation will illuminate. Pushing the GPU switch will allow automatic operation for powering with AC ground power. If ground power source priority conditions are met, the EPAC will close and avail annunciation inside the switch changes to in use, and the same change in indication takes place on the exterior AC GPU panel. The ground service switch on the exterior AC GPU panel allows activation of the system from outside the airplane. By pushing the exterior AC GPU button, the avail indication inside the switch changes into in use to feed the ground service buses. The ground service switch, located on the forward galley, also performs the same function. When pushed with AC external power available, the ground service buses can be energized. The DC ground power system accepts 28-volt DC. Dedicated system relay logic in the Auxiliary Integrated Control Center, AICC, controls the operation of the system. Note: only the exterior ground power unit switch, GPU, on the exterior panel controls the ground power DC contactor, EPDC. If power quality requirements are satisfied, the avail annunciation will illuminate. The EPDC remains open. Pushing the GPU switch will change the avail annunciation inside the switch to in use. If APU start is initiated, the APU starter contactor, ASC, will close.
For use on ground or in flight, the cockpit contains two AC electrical power outlets, one in the left and one in the right console, to allow the flight crew or maintenance personnel to connect their respective laptops or other portable electronic device.
During normal operation, three-phase 115-volt AC 400 Hz power is provided to the cockpit electrical outlet system by the AC bus 2 and converted into 110-volt AC 60 Hz. The system is switched on and off via the PC outlet control switch. When set to on, the green outlet LEDs illuminate to indicate that the corresponding outlet is available. The output 110-volt AC 60 Hz is only ready for use when a device is plugged into the outlet unit. If the connector is not properly plugged into the electrical outlet, the power will not be available. It is then necessary to remove the plug and connect it again. Whenever the electrical outlet system is activated and for any reason a cabin decompression event occurs, the three-phase AC power supply will be interrupted. After the pressure is considered normal again, the system can be reset through the PC outlet control switch.
Cabin PC power system. The optional PC power system is designed to supply passenger seats with a 110-volt 60 Hz AC power for personal electronic devices, PED, such as laptop computers or other electronic devices. The AC Bus 1 supplies power to the converters, which then provide AC power to all passenger seat outlets. The PC power system operates only if the electrical system is operating in normal mode. In case of loss of any of the electrical generators, the system will not operate. The PC Power IFE panel controls the system and is installed on the control pedestal. The galley master switch, installed on the flight attendant panel, also turns off the system. Cabin PC power outlet. Each outlet incorporates a LED that is visible to the passenger and indicates that AC power is available. The green color indicates power supply at outlets, and the red color indicates power not available. The LED is turned off when the system is not energized. The outlet provides power for use only when the plug is correctly connected into the socket and portable electronic device power is enabled. Cabin crew can monitor the power outlets in use by an outlets in use panel installed in the passenger cabin. Cabin PC power protections. A self-test is performed during power-up and shuts down the system if an error is detected. The system provides protection against undervoltage, overvoltage, overcurrent, short circuit, and overtemperature. The system is also turned off automatically in case of cabin decompression. Pressing the cabin PC power button on the control panel resets the system.